definite integral involving a power of cosine. We want to find the integral from 0 to pi over 2 of cosine to the fifth power of x dx. To solve this, we'll use the reduction formula for powers of cosine. The key identity we'll use is cosine to the n power equals cosine to the n minus 2 power times cosine squared, which equals cosine to the n minus 2 power times 1 minus sine squared. In our case, n equals 5, so let's substitute that in. Our integral becomes the integral from 0 to pi over 2 of cosine cubed x times 1 minus sine squared x dx. Now comes the clever part. We'll make a substitution, like u equals sine of x. This means that do equals cosine x dx. When x equals 0, u equals 0, and when x equals pi over 2, u equals 1. After substitution, our integral becomes the integral from 0 to 1 of 1 minus u squared squared do. Let's expand 1 minus u squared squared. This gives us 1 minus 2 u squared plus u to the fourth. Now we can integrate term by term. The integral of 1 is u, the integral of negative 2 u squared is negative 2/3 u cubed, and the integral of u to the fourth is u to the fifth over 5. Let's evaluate at the limits. When u equals 1, we get 1 minus 2/3 plus 1/5. When u equals 0, we get 0 minus 0 plus 0. This gives us 1 minus 2/3 plus 1/5. To get our final answer, let's find a common denominator of 15. 1 becomes 15/15, negative 2/3 becomes negative 10/15, and 1/5 becomes 3/15. Adding these fractions gives us 8/15, which is our final answer. And that's how we evaluate this definite integral, using substitution and the reduction formula for powers of cosine. The key steps were using the reduction formula, making a clever substitution, and carefully working through the algebra.